Welcome, everyone. Today, we're going to dive into a challenge that every single manager, whether you're at a startup or a Fortune 500 company, has to face every single day. We're going to take a concept that might sound a little intimidating, multivariable calculus, and show you how it's not just a bunch of equations on a blackboard. It's actually a powerful and surprisingly intuitive tool that can help you find your company's true profit potential.
Okay, so let's start with a classic scenario. Just imagine you're in the driver's seat. You've got two main levers you can pull, the price you set for your product and the quantity you decide to produce. But, and this is the beautiful complexity of business, they are completely intertwined. You pull one lever and the other one moves. You tweak the price and suddenly your demand shifts. You ramp up production and your costs start to change. So the real question is, how in the world do you find that perfect, razor-thin balance that gives you the absolute maximum profit? This isn't just some hypothetical question from a textbook. This is the daily high-wire act of running a business. It's this dynamic, interconnected challenge that, for our chat today, we're going to call the two-lever problem. And I want to be really clear. Getting a handle on this isn't just about passing an exam. It's absolutely fundamental to being an effective and, of course, a profitable leader. The really crucial thing to get here, the thing that makes this so darn tricky, is this interdependence. You adjust the price, and you're not just changing how much money you make per item, you are fundamentally changing how many people are going to buy it in the first place. Then you change your production volume, and you're messing with things like economies of scale, your supply chain logistics, your marginal costs. You see, every single piece of this puzzle is connected to every other piece. Now, the tools you probably picked up in a first-year calculus class, finding the peak of a simple curve with just one variable, that's a fantastic start. But for a real-world puzzle like this, well, it's just not quite enough. We need a more powerful toolkit, one that's actually designed for a multi-dimensional world like the one we live in. And this right here, this is a core idea for your entire career. Trying to solve a two-lever problem with a one-lever tool is, well, it's a recipe for failure. It's kind of like trying to navigate a whole city using just a compass instead of a map. Sure, you might get one direction right, but you are going to miss the bigger picture and all the opportunities that come with it entirely. This slide just illustrates that conceptual leap we have to make so perfectly. On the left, you've got that limited, almost tunnel vision view, right? Looking at profit versus just price, or profit versus just quantity. But on the right, that's where the real magic happens. We've got a holistic, interconnected model that's analyzing how profit responds to changes in price and quantity at the exact same time. This is how a real business actually works. So this brings us to the hero of our story today, multivariable calculus. Now, please don't let the name spook you. Just think of it like this. It is the mathematical framework that was built specifically to solve complex problems that have more than one moving part. It's simply the language we need to describe and solve our two-lever problem. All right, now I want to give you a really powerful mental model. It's a visual analogy that I think is going to make this whole thing just click into place. And this isn't just some trick to help you on an exam. This is a way of thinking that you're going to use for decades. So let's build this picture in our minds together. I want you to completely reimagine what profit looks like. Stop thinking about it as a line on a flat two-dimensional graph. Instead, I want you to picture your company's entire profit potential as this vast three-dimensional landscape, like a whole mountain range with towering peaks, deep valleys, and rolling hills. Your job as a leader is to find the single highest summit in that entire range. That point, and only that point, represents your maximum possible profit. And this is the key. On this profit map, your price is like the east-west coordinate, and your quantity is the north-south coordinate. Any combination of those two things is a specific spot on the landscape. Multivariable calculus, then, isn't just a formula. It's like a hyper-accurate GPS that analyzes the entire topography of that mountain range and gives you the precise coordinates to reach that highest peak. Okay, so this all sounds really cool, but how does it actually get used, in our real boardroom? How do strategists and analysts turn this concept into actual money-making decisions? Let's walk through the logic. The process really breaks down into three key steps. First, you build a profit function. That's just a mathematical model of your business, linking your inputs, like price and quantity, to your output, which is profit. Second, you use that function to visualize that entire profit mountain. And finally, you use a special tool for multivariable calculus called partial differentiation. Now think of it this way. To find a peak, you have to find the one spot that's flat in all directions, right? Partial differentiation is brilliant because it lets us check the slope in the price direction and then check it in the quantity direction separately. We find the one spot on that map where both of those slopes are 0. That's our summit. Now, as a future leader, you're not going to be doing these calculations by hand, but understanding the logic behind it is absolutely critical for you to make informed decisions.
And isn't that just a beautiful idea? When you are standing on the absolute highest point of a mountain, the ground right underneath your feet is, for that one moment, perfectly flat. The slope to the north, south, east, and west is 0. That is the mathematical signal that calculus is hunting for. It's that one point where a tiny little change in price or quantity no longer increases your profit. You've made it. You're at the top.
Now that we understand the power of doing it this way, let's talk about the most common and, frankly, the most costly mistake that people make. It's a trap that so many students and even experienced managers fall into, but it's one that you can very easily avoid once you learn to see the whole landscape.
So the key takeaway here is this. Optimizing for just one variable in isolation will lead to suboptimal results. I mean, every single time. It's the marketing department finding the best price without ever talking to the operations team, or the ops team finding the cheapest quantity to produce without talking to marketing. It's siloed thinking, and it is a guaranteed way to leave money on the table. When you make that mistake, you're basically trying to climb that mountain with one eye closed. You might find a local ridge, maybe a false peak, a point that looks like the top from your limited perspective, but you will almost certainly miss the true summit, simply because you failed to see the whole integrated picture. And of course, in the real world, it's never just 2 levers, is it? It's an entire control panel. You've got price, quantity, marketing spend, R&D budgets, supply chain costs, dozens more. The crucial point is that this 2-variable profit mountain we've been exploring today, that is the foundational logic that powers the incredibly complex software and AI tools that modern businesses use to navigate this vast, multidimensional landscape every day. So here's the final thought I want to leave you with. Learning to see the world in multiple, interdependent variables isn't just about passing a math class. It's about fundamentally upgrading your strategic mindset. This framework, it doesn't just apply to profit. What about maximizing your market share or customer satisfaction? What about social impact? The question is, now that you know how to see these invisible mountains, which peaks will you choose to climb?